Okay, 1.5 linear inequalities. So we're going to solve for x plus 1 greater than 9, add 1 to both sides. We get x greater than 10. Now we're going to put that on a number line. So when we do a number line, label negative infinity to infinity with arrows. And then since we have a greater than symbol, which does not include the value, we are going to use a parentheses, which signifies does not include that value. And then I squiggle shade in the direction. So any value strictly greater than 10 is a solution or makes that statement true. Then in interval notation, we're going to have parentheses 10 to infinity. These two things and the inequality itself all say the exact same thing. So this says any x value strictly greater than 10. Then we have something called a three-part inequality. The variable is in the middle. And then we have a less than or equal to, and then another less than or equal to. So when we go and add 2, we add to all three parts. So we get this statement in inequality form. -1 less than or equal to x less than or equal to 7. So when we put that on a number line, x is between and includes -1 and 7. So that's why we'll have square brackets, because that signifies that we are including that value. And then in interval notation, bracket -1, comma 7 bracket. This interval notation, this number line, and this inequality all say the same thing. Then we have a compound inequality, which is just two inequalities with an or statement in between. So what I want you to do is look at the first statement, x less than 4, and transfer that to a number line. So we already know how to do that. Look at the second statement, x greater than 10. Transfer that to the number line. So this statement, x less than 4 or x greater than 10, means x can be any value over here, or x can be any value over here. Then if we want to write that using interval notation, we write each portion of the interval notation, and then or is symbolized by the union symbol. So this part of the number line is this part of the interval notation. All of these right here say x greater than 10, or, and or. And that is its own symbol. It is not a capital U. In 1.6, we have absolute value equations and inequalities. So first, let's talk about the definition of absolute value. The definition is the unit distance from 0. So absolute value gives us a distance measurement, whereas something like x equals 8 is a description of a position. So if I were to plot x equals 8, I would put a dot at x equals 8, and that tells me where that dot is. But if I said the absolute value of x equals 8, that is telling me that the distance from 0 is 8. So absolute value of x equals 8 tells me distance equals 8, distance equals 8. So that actually shows up at two locations on the number line. The distance from 0 being 8 occurs when x is -8 and also when x is 8. So the absolute value of x equals 8 means x equals 8 or x equals -8. It is one of those two because both of those have a distance of 0 that fit the original statement. So if we go and solve this absolute value equation, we cannot subtract -1 from the absolute value because that is a statement about distance. So we need to transform to a statement about position. The technical term is called equivalent form. Now the way we do that is we write the position statement x plus 1 equals 7 or x plus 1 equals -7, because remember, this represents a distance, but this represents a position. And then we can solve like normal, so -1, -1, -1, and we get x equals 6 or x equals -8. So since this is a finite number of solutions and it is not an interval, we are writing a list. So curly bracket 6 comma -8, that is set notation. Set notation, which is different than interval notation. Interval notation says all of those numbers. Set notation is a list, and it does not matter. It is not in numerical order, so you can put the -8 first if you want. But set notation is just a list of those unique solutions. So then we have absolute value inequalities. So I have an example here, absolute value of x less than 5, and then we need to learn how to write that in equivalent form. So if you have a less than or equal to, then you're going to change that to a 3-part. So absolute value of x less than 5, its equivalent form is -5 less than x less than 5. And so then if you did that same thing, but you had equal to, then you would have -5 less than or equal to x less than or equal to 5. Now, then when we have a greater than or equal to, we change to a compound inequality. X less than -5 or x greater than 5. And then the only thing that's going to change if we have a greater than or equal to is x less than or equal to -5 or x greater than or equal to 5. So a note here, the absolute value of x being strictly less than 0 does not exist because there is no negative distance. And then an absolute value of x being strictly greater than 0 would be all real numbers, because any positive or any real number's absolute value is positive. So therefore that would be greater than 0. Okay, so here's a common mistake that I hate to even bring up, but when we have something like this, it does not change to -5 greater than x greater than 5. This is in fact a nonsense statement. Let's see if we can figure out why. So this says right here that -5 is greater than x. -5 greater than x. So that means that x has to be smaller than -5. Okay, that makes sense. But then if we have this side, this says x is greater than 5. Well, both of those things can't be true, obviously. X can't be bigger than 5 and also smaller than -5. So that is just a nonsense statement, and it is inaccurate to use that as an equivalent form. The equivalent form is the compound inequality. Okay, let's take a look at an example. We have absolute value of 2x minus 3 less than or equal to 9. So the equivalent form is to change to a 3-part, so -9, and then what's inside the absolute value. And then 9, we've got less than or equal to, less than or equal to. Add 3, divide by 2, and then we get this inequality. -3 less than or equal to x less than or equal to 6. So this is the solved inequality. Below that is the number line, and below that is the solution using interval notation. All of these, this, and this, are synonymous, meaning they say exactly the same thing, just a different representation of that statement. Then we've got one with a greater than, so x minus 5 and absolute value greater than 2, so we change that to equivalent form. X minus 5 less than negative 2, or x minus 5 greater than 2. So then we add 5 to both sides, x less than 3, or x greater than 7. And this is the solved inequality. Put that on the number line, just like we did in the previous section. And then when you write interval notation, remember we're going to have the union symbol.